close that. From here, I'm going to jump back over to the design space and just right click on this, and I'm going to tell it I want to make a drawing. So in here, within the create drawing dialog box, I don't really have to change a whole lot. I do want to switch back to the ASME standard as opposed to the ISO. I could create a new template file and use that template. In my case, I don't have any templates made. But from here, a B size should be fine for this component. And from here, I'm just going to hit OK on that and let this generate the drawing. So from here, I do need to specify where my base view is, but once I select that, the rest of the did I click the wrong button? I think I might have. Don't save. Let me try this again. Automatic. I did not notice that it had switched over to the automatic or not automatic mode. So just going to click through these options again. It's a B size. As far as the sheet creation, we're going to use the first level. There's no hierarchy in this file, so it doesn't need any of those options. But from here, we'll see that it's going to generate the working drawing. It can take a couple minutes. While this is running in here, we do have the notification center up here, and the drawing is ready. But if I come up here and look, we also see that our static stress analysis is done. And so from here, I can click on the link and view the results. And so within the space, it's going to give us some result details. We can see that our minimum safety factor is well within the range, and it's giving me some feedback about potential recommendations, right? Potentially use the shape optimization tool to remove unnecessary material, maybe try less material or switch to a different component, or even, go down to the generative design environment and try to remove weight from the component. And so, from here, we have all of our results. We can very quickly jump back and forth through, see the total amount of stress on this component, see how it's distorting it. Right now, we're seeing the results are exaggerated within the view. And I can come in and change the display of this to not be, the exaggerated display. And in here, we can see that displacement is very, very minor on this component. So in this case, 0.027 inches or millimeters. So very, very small amount of displacement in this part, which tells me that this overall area might be, overly engineered. So from here, I can step out of the result space, jump back over design. I could even go into generative design in here. Get the learning panel out of the way. Create the study. Yep. And I'm not going to go through all the steps of this. I didn't create one on this component already, but the general idea behind this is we can specify specific areas we want to preserve, specify specific areas we have to avoid. Obviously, we have a starting shape, and then we can specify some objectives within this as far as like minimizing mass. As we do this, we also specify some conditions that this is going to run through, basically what we did in the static stress analysis environment, where you would say these are pinned, this has got a 250-pound load in this direction, in the X direction. And then it would go through and look at the component based on the material that we specified, and it would give me some potential options about removing mass from the shape. And as we finish that process, it would then generate essentially a new body within this cast lever component that we could then use to either subtract from the existing, use as a Boolean operation, different, tons of different options available to us to simplify this design. Now, because I'm still working in the cast lever, if I were to go in and update this body, all I would have to do is jump right back into simulation, regenerate the mesh, and then update through resolve for the results. During this whole process, right, the drawing was being created in the background. And in the drawing, we can see in here that it created a number of dimensions and view placements on its own for me. However, I can specify different ways I want to potentially dimension this. So I can use ordinates, maybe some symmetric dimensions, really gross tolerance stacking chains in this case, which really aren't too bad. But yeah, just a number of different potential options available to me on how I might want to create the dimensions. Now in here, we can also shift where the potential datums are. I can manually select a given location as a guide for all of my dimensions in the part, and so on. From here, there's only really one of these that I need to fix, and this one right here is a little bit unclean. It doesn't know exactly where to place things like dimension text. It might do things like this where it overlaps dimensions, so I might want to consider moving this to the bottom side and updating positions of these. But it's done a lot of the work for me as far as creating the working drawing. At this point, I can then come in and finalize it or clean it up from here in order to try to end with a functional working drawing. All of your standard dimensioning and annotative tools are available. So creating center lines, center marks, other annotative text, and so on, symbology, you name it, it's all here. It does create the drawings as its own separate file. So I am going to save this one off. And we'll see here that file gets saved. Also note in the Fusion environment, the data page here, it keeps track of the versions of them. So at any time, if I needed to jump back in time, I could do so.